Hey guys, this is Josh Myers, and I am bringing you the fifth video of the chemistry series on the Academia on Demand channel. And today we are going to be talking about elemental properties. In a previous video, we had been left with the idea of this thing called electronegativity and how it affects chemical bonding. We will talk a lot about that, how exactly it works within the bond, and we will discuss a lot more about that in later videos in the next couple ones. Okay, so now first property we are going to talk about, and these things properties, they are characteristics of elements in the periodic table. The first one we are going to talk about is called ionization energy. Ionization energy. And previously we talked about the idea of elements gaining and losing electrons and taking on a charge. And this is very much associated with what ionization energy represents. What ionization energy is the energy required for an element to lose a single electron. And we will draw a picture out and we will get a very good idea of what losing an electron means. Energy required to lose one electron. And so let's draw out the lithium atom, because it is very easy. It only has 3 protons, 3 neutrons, and 3 electrons. Let's draw it out. Use our circular energy levels, just as we've been taught in the previous 4 videos, and put our 2 electrons in the first one, in the first energy level, and then in the second energy level we are going to put 1 electron. 1 electron. So now this idea of ionization is when the lithium atom loses its electron. It loses its electron. The attraction between the nucleus, the positive protons, and the negative electrons is broken. So this electron is released, and what is required of this is when energy, there's this idea of adding energy to a mass. And we will talk a lot more about this when we talk about kinetics and the movement of molecules. But just as a molecule, just as this atom has mass, an electron also has mass. And so this electron is normally attracted to the positive nucleus. It has an electrical attraction to this positive charge. But when energy is added to it, it has this tendency to want to move. It gains kinetic energy. Kinetic energy increases. Kinetic energy increases. It goes up. So eventually when at the point where the energy added is equal to, so energy added is equal to the energy contained in the attraction. Contained in attraction. The electron will be released. The electron is released. And this can be written in an equation form that will allow us to very easily demonstrate the idea of releasing this electron. So lithium solid. So let's just say lithium. Let's ignore states for a second. We will talk about states in a later video. Lithium, when it is ionized, it will become Li+. It will lose a negative charge, thus taking on a positive charge, and it will be left releasing an electron. However, this can happen multiple times. This next electron in the first energy level can also be released. And so this is written in the equation, the Li positive ionized is equal to Li2+ plus electron. And what we're seeing here is that electrons can be released as energy is absorbed one after the other. However, one important thing to note is the idea that as more electrons are released, the amount of energy required to release them increases. Electrons are released, energy increases. Energy increases. Energy increases. All right, so this wraps up that first elemental property that we will relate more to the periodic table in the next video. And now we are going to talk about this thing called atomic radius. Once I erase all this stuff, all this dandy stuff. Okay, now we are ready to start the next one. We are ready to start. So this next property is called atomic radius. And this is exactly what you'd expect. It is the distance, if you draw out that atom again, the distance from the center, let's draw a hydrogen atom, so positive. The distance from the center of the nucleus to the outside, the outermost space of the atom. So in the hydrogen atom, which would have the smallest, sorry, not the smallest, helium has the smallest, and we will talk about why in the next video, but it will have a very small atomic radius relative to other atoms because it only has one energy level. So it will have a lesser distance between the middle of the nucleus and the outside of the atom. And this actually, very interestingly, cannot be measured directly from observing one atom. This idea of atomic radius can only be measured when this hydrogen atom or any atom is bonded with another atom. It's bonded, let's say this atom is fluorine. It's bonded with fluorine. And as we know, this is a covalent bond. And that is because of electronegativity, which we will talk about very soon. And so this idea of the atomic radius being the halfway. So when in the bond HF, this line will represent the bond for a second, they measure the atomic radius based on the halfway point between the nucleus of the hydrogen and the nucleus of the fluorine. And that is the way that they will know how scientists will discover how the atomic radius of hydrogen, how large it is. One important thing to note when you relate it to ionization energy is the idea that when atoms lose electrons, AR, which is atomic radius, it decreases. And the reason for this is because if there are an equal number of electrons and protons in an atom, and then it loses an electron, this means that they're ratio-wise, the ratio between the number of protons which are attracting the electrons increases, which means there are more protons to attract fewer electrons in this atom, which means that the electrons will be pulled closer to the nucleus. They will become closer to the nucleus. They will be pulled in tighter by this idea of positive charge. So now we need to talk about the idea of electron affinity before we finally get to the electronegativity idea. Alright, so electron affinity. And electron affinity is not something that we will discuss too much in later videos. The only video that may be discussed is in this concept that we will talk about called the Born-Haber cycle. Electron affinity. And it is the opposite of ionization energy in the sense that it is the energy gained, the gained energy gained when an atom accepts an electron. Accepts an electron. And it makes sense. It makes sense that there is energy gained when an atom accepts an electron. Because let's just say, let's draw out our hydrogen again. Let's draw out our hydrogen with our single proton and single electron around the nucleus. Electron right here. Let's just say that this hydrogen accepts an electron, and it now has 2 electrons. It will be hydrogen with a negative charge. It has accepted a negative charge. Well, now what has happened is that an attraction has now taken place between that electron that has just been accepted and the positive charge of the nucleus. And this results in an increase in a state of energy gain of this atom. And so what ends up happening is that the energy is actually released from the atom, in the sense that energy is not required to make this happen. And this is why often, for almost all elements, any time that an electron, at least the first time an electron is accepted, first time, will always result in a stabilization. And this is what I mean by energy is released, or that it is gained, or like in subsequently released, and that it becomes more stable. Stability. And we will relate this to the periodic table in the next video. I just want to wrap up now with the electronegativity we talked about in the last video. Electronegativity, it fits right into the word electron. Negativity, electronegativity. And as I described before, this is the concept of the tendency to attract electrons in a bond. So let's go back to the example we had in the last video with lithium and fluorine. So lithium, let's just, as we did before, represent this bond, this bond, even though we know that it's actually the electron is transferred to the fluorine, that the fluorine takes the electron for itself. Let's pretend this bond is represented by this line, and there's an electron here and an electron here. Well, fluorine has a much higher En, electronegativity, than lithium. And what this means is that fluorine will pull these electrons much, much closer to it. And this is why, in fact, in this example, it will take them completely. It will become a negative charge. It will take the negative charge from the lithium. Lithium will become positive charge. And this is why that ionic attraction is created that is so much stronger than the sharing of the electrons, as in the previous example between the 2 nitrogen atoms. And here, this is also interesting because the 2 nitrogen atoms have the same electronegativity. So by definition, they will cancel each other out. And these electrons will sit right here in the middle, and this is actually a relatively accurate depiction of what happens. This line actually represents this sort of idea of the electrical energy collected here, because they do not shift to one atom or the other, because the electronegativity is the same. The nitrogens attract the electrons the exact same amount. And now the last idea I'd like to leave you with before I have to say adios is the idea that electronegativity is just like kids playing tug-of-war on the schoolyard. You have kid playing tug-of-war, and this rope And in the lithium example, the fluorine would be the big kid. He'd be the one that would pull the rope right out from underneath the smaller kid. So if this were fluorine, and lithium, he'd be pulling this rope and he would be winning. He would be absolutely smushing the lithium kid. And this really is an analogy that is very reflective of what is happening. The fluorine is simply, it is so much better at attracting these electrons for reasons that we will discuss in future videos very, very soon. And we will diversify our understanding of this idea. So for now, have a nice night, everyone. Adios.